All right, so for the I2C protocols, there really are only just two. There's one where you write to the slave, and the other one where you read data from the slave. So we're going to first talk about the write protocol, which is the easier one of the two. So just to get some context here, this is what the master is outputting, and this is what the slave is outputting. So the first part is the master sends a start signal. So the start signal just pretty much initiates an I2C communication and starts to prepare itself to actually enable communications. The next one is the device address or the slave address. So the slave address pretty much just selects which slave it wants to talk to. This one right here is the write bit, or this is the read or write bit. So what this one pretty much helps to define is whether or not you actually want to read from the slave or write from the slave. So in this case, you want to write from it, so you use the write bit. And the write bit is typically a 0. All right, so after that, the slave is going to go ahead and acknowledge that signal. So this is the acknowledge signal. So it's going to go ahead and tell the master that it received this data and it's ready for the next set of data to be processed. So the next one is the register address. So the register address pretty much indicates in the slave which memory block you want to actually write to. So in the case with digital devices, the register could mean anything. So it could mean like the storage of the color outputs for the case of our color sensor, or in this case like sensitivity options or calibration options. So that's what the register address that you want to write to. You go ahead and write it there, and then once that is sent, the slave is going to go ahead and acknowledge again just to make sure that everything got transferred through. And then once that happens, the master is going to go ahead and send the data that it wants to write in that specific register. And then once that happens and the slave has all that stuff written, it's going to go ahead and send another acknowledge signal. And once the acknowledge signal happens, then the master is going to go ahead and write a stop signal. So the stop signal just terminates the I2C communication. And that's the write command. All right, we're going to go ahead and talk about the read command in I2C. So you can see in the very beginning over here, it's actually pretty much the same thing as the write command. So just to remind you, this is start. So the master is going to go ahead and send out a start signal to initiate the communication. Then it's going to send out the slave address. Then it's going to send out the write command or the write signal. And then the slave is going to acknowledge it. And then once that happens, the master is going to send out the register address that it wants to read. So as opposed to the write command, this is the one that instead of writing to this register, it's going to read this register. So register to read. Okay, once that happens, again, the slave is going to send out the acknowledge. So the very beginning is pretty much exactly like the write command. All right, so then, however, at the very end of this, instead of actually sending out the thing that it wants to write, it's now going to send out this one thing called a repeated start signal. So what this pretty much means is the master is pretty much telling the slave that it hasn't stopped talking to it yet, and it's going to keep communicating with it until it sends out the stop signal. So with that in mind, it's going to go ahead and resend out the slave address just to ensure that the slave is still being in contact with this entire communication, and it's going to send out the read command. Okay, so once the slave acknowledges it, it's then going to send out the data of that register. So, so this is the data from register. Which is then, the master is then going to interpret that. And then once it interprets that, it's going to send out this thing called a not acknowledge. Now, it's not like the master didn't receive it at all. It's just that as opposed to acknowledge, which is typically either a 1 or a 0, the not acknowledge is the opposite of that, which terminates the communication. And then it's going to send the stop signal to go ahead and terminate all of I2C communications. So this is the read command. So just to go ahead and do this all over again, just to review, the master is going to send out a start signal, which pretty much initiates the I2C. Then it's going to send out the slave address, which is used to actually tell a slave in particular which one it wants to talk to. Then it's going to send out the write command. The slave is going to acknowledge it if it received that data, and then the master is going to send out which register it wants to read. Then the slave is going to acknowledge that, and then once that happens, the master is going to send out a repeated start just to keep the communication going. It's going to resend the slave address to just so that it keeps talking to that particular slave device that it wants to talk to. It sends out the read command to enable that it wants to read something from the slave. The slave will therefore acknowledge it and will send out that the data from that particular register. The master will say either to acknowledge it or didn't acknowledge it, and then it'll stop the communications.